So after applying the loads, now we'll analyze our structure. So click on yes to save and click on save. To do that, so let us click on analyze print option. So here you can say all. So to print everything, load data, static checks, static loads, mode saves, both. So click on add and click on close. So we have added the command to analyze our structure. Now we will analyze it. So click on analyze here. After that, click on run analysis. So save it. So we got 0 errors, we got 0 warnings, and we got 0 nodes. If you want to see the output file, click on view output file and click on done. So now you can see the output file. Oops. You can see the different inputs over here, and if you go on, you can see the load type. Okay, so because we have printed this time, all right, so we can see the load type live load, and we can see a loading type applied joint equivalent loads. And also if you move on, so you can see different calculations, and also you can see external and internal joint loads, and it's finished. Okay, so let's close this. And after that, now let us see the shear force and bending moment diagram of this structure. So what we'll do, we'll go to the post processing option. So let's click on post processing and make sure that these two loads are in the selected window. Okay, if they are not, suppose they are not, okay, so select these two loads or just click this option. So these two arrows, okay, click them, so they will be on the selected window, and click on OK. Let us maximize it. Let us remove this 3 meter distance that is written over here. For that, select this option, remove all node to node distance display. Select this and it will be removed. Now let us first see the reactions at the supports. For that, go to results. You can check from here as well. So but let us go to results and click on view value. We'll see the reactions. So go to reactions tab. So the reactions are in upward direction as well as in the X direction. So we'll select these two options, and bending will be in the Z direction. So we'll select the Z if there is any. So click on annotate. So you can see the various X as well as Y and the moment values. So there is no movement, and the movement value is pretty much less. And also X, the reaction in the X direction is also not much high. The Y reaction is pretty much appreciable. Okay, so click on remove all. So next thing that we want to see is beam results. So let us see the bending maximum values and click on annotate. So in order to annotate bending, you must have bending diagram on. Please switch on the bending diagram. So click on OK. So here you have to switch on the bending diagram first. So here it says it is the Fx means the axial force, Fy is the shear force in the Y direction, Fz means the shear force in the Z direction, Mx is the movement in the X direction or the torsion, My is the bending moment in the Y direction, and Mz is the moment that we want. So click on this option. So you can see the bending, okay, in the Z direction. So if we see the bending in the Y direction, so uncheck Z, so there is not much bending, or the bending is 0. So click on Z and uncheck this. Okay, alright, so let us see the diagram. To see the diagram, hold control, and after that, so close this first. So hold control, and after that move your middle mouse button or the mouse wheel in the clockwise direction. So you can see the values, okay, the scale values. So this is how the bending moment looks like. You can see that the bending moment in the columns, so this also happens in the buildings, okay, the same thing will happen in the buildings, columns and the beams. You can see the maximum bending moment is at near the support. Here also it's near the support, and in the beam also the there is the negative moment near the support, and there is the positive movement at the center. So the maximum movement is either at the support, so depends, and or at the center. Also you can see the movement values at the support as well. So go to results, and after that click on view value, and let us see the beam results at the ends. Also click on annotate, so you can see the end movements as well. So it's 0 because it's a hinge support. And okay, so here it's minus 0.460 kilonewton meter, 0.954, 0.954. As the load values are pretty much less, and the beam and the column sections are pretty much high, the movement values are less. Next, let us see the shear. So uncheck these two options. We will see the shear in the y direction first. So click on ends and click on maximum and click on annotate. Okay, so uncheck this maximum option and click on ends only and click on annotate, and uncheck this moment value. Okay, so bending at Z. So now the shear force has been displayed, but it is not the scale. So what we're gonna do is that hit Control, and after that move your mouse in the middle mouse button or the mouse wheel in the clockwise direction. As the shear force value is pretty much low, so let us see first the maximum value and click on annotate. You can see that it is showing the highly exaggerated view of the beam, so bending shape of the beam, but you cannot see much of the shear force here. It is because the size of the beams and column is pretty much high as compared to the load applied on it. Hit Control and keep increasing it, so it's only, so you can see that the maximum shear force is minus 13 kilonewton. Here also it's 3 kilonewton and it's 0.283, and not much of the shear is in the columns as well. So okay, so now let us see the displacement. So click on maximum results and click on annotate. You can see the maximum displacement values. The maximum displacement of this column is 0.023 mm, which is pretty much low, almost negligible, you can say that. So 1 mm is almost negligible, so it is 0.023 mm. So you can imagine how low this value is. Let us close this. This is how you model a frame, apply the loads, apply the supports, and see the bending moment diagram, shear force, and the displacement. If you want to see the shear force and the bending moment diagram of each individual member, what you have to do, left click on this option, beams cursor, and after that, so double click on this column. If you want to see the bending moment diagram of this column, so double click here and go to shear bending. So right now it's the bending in the Z direction has been shown. Similarly, you can see the shear force in the Y direction. So this is the shear force in the Y direction, minus 0.28 kilonewton, which is pretty much low. Okay, this is how you analyze a frame.
Please keep practicing regularly. Regular practice encourages active application of knowledge gained. Till then, goodbye. Subscribe to the channel and turn on the notification bell so that you receive videos on time. Activating the notification bell ensures viewers receive updates about new upload.